is when you take a binomial and raise it to a power. So if we had like x plus 1 and we wanted to raise it to the 5th power, we would have to multiply x plus 1 times itself 5 times, and that would be an absolute nightmare. So we are going to use the binomial theorem to do that today. So the first thing we need to know is Pascal's triangle. Pascal is that guy in purple back there. He lived in the 1600s, and he kind of figured out a pattern to use to do this binomial expansion. And it's great. That was one of his big contributions to mathematics. So I'm going to start the triangle. I'm going to see if you guys can figure out the pattern. So the very top of the triangle is a 1. Whoops, is a 1. The next rows are both 1s also. All right, and then we have 1, 2, 1. 1, 3, 3, 1. So obviously, first and last are going to be 1s. Do you guys know how to get the next one? What do you think it is? It is a 4. And then? Oh, 6. Good. And then a 4. And then a 1. So what they figured out is to get this number, you're going to add, to get this number, you're going to add these two. All right, to get this number, you're going to add those two, and so on. All right, so the next row is going to be 1, 5, 10, 10, 5, 1. All right, so this is extremely helpful in doing the expansion. And today, I'm sure when you guys are doing your homework, you're just going to look at this triangle, but hopefully when you need to do it on a test, you can just recreate it, make it as big as you need to do whatever problem you need. Now, you guys have actually already used a small portion of the Pascal's triangle in algebra. So whenever you would do a problem where you're squaring something like a plus b, you square the a, multiply them together and multiply by 2, and then square the b. So this is like a 1, 2, 1 that just came from the first row or the third row of Pascal's triangle. So you were using it and didn't even know it. All right, so I'm going to write out like the rule for binomial expansion. When I did this in my last class, they were freaking out a little bit. It looks difficult in an abstract form, but when we start doing it, you're going to be fine. I promise you're going to be fine. All right, so we start off with some coefficient from Pascal's triangle. So we're just going to put a blank. And what we're doing is we're taking a plus b and raising it to the n. So after that first coefficient, you'll have a raised to the n. All right, and then we'll have plus. Is that a minus? It's a blank. And then you're going to have another blank for something from Pascal's triangle. All right, and then the power on the a is going to go down by 1. So it's going to be a minus 1. And the power on the b is going to go up by 1. So it originally was technically 0, but now it's a 1. All right, and then we have a plus and then a blank. So we'll use something from Pascal's triangle. And then the power on the a is going to go down by 1 again. The power on the b is going to go up. And that pattern continues until you get to the last term where you have a blank for something from Pascal's triangle. And the a term is gone. There's no more a. It's gone down to 0. What do you think the power on the b is? It's going to keep going up. So it was 2 here. It's going to keep going up. Anybody? And good. So it's going to be whatever the power originally was. Oh, no, that looks weird. It's going to be fine, I promise. All right, and then all these blanks, we're going to get these from the appropriate row of Pascal's triangle. All right, so we're going to hold off on the division notes and skip down, check for understanding, and go ahead and do a couple of binomial theorem problems. So on number 1, we're going to take this function, y equals the quantity x minus 4 quantity cubed, and we're going to write it in standard form. So standard form, if you guys remember, there's no parentheses. It's just term after term after term, and your powers are in descending order. Now we have to decide what row to use for Pascal's triangle. And so if the power is a 3, we're going to go looking at the rows, find the row that the second number is a 3. Those are the coefficients we're going to use. So the first one is always 1. So it's up to you. You can write the 1 or you cannot write the 1. And then it's going to be that x raised to the third. All right, then we're going to go to that row we were talking about. The coefficient we're going to use is 3. And the power on the x is going to go down. And then we have a power on the negative 4 that's going to go up. Then looking at Pascal's triangle, the next coefficient is a 3. And the power on the x is going to go down. And the power on the 4 is going to go up. All right, and then our last coefficient is 1. There is no more x because the power is going down to 0, which means it's not going to be there. And the power on the negative 4 is going to go up to. All right, and then this step, if you guys wanted to use your calculator on this, it's fine. I know you could probably do it in your head if you needed to, but if you don't want to like raise numbers to the 5th power or whatever, it's okay. So this is just going to be x cubed, and then we do 3 times negative 4, and then 3 times negative 4 squared, and you can just type it in the calculator just like that. Make sure the negative is in parentheses though, or it's going to mess you up. It's going to be 48x. And then negative 4 cubed is negative 64. All right, that's binomial expansion. What do you guys notice about the powers here?
X values decrease and the B values decrease.
Right.
B values increase.
Very good. Anything else? Specifically, like looking at the numbers? They're either going to be whatever this power is, or they're going to add to be whatever that power is. So that every step, these powers add to give you that one every single time. So it's really easy to kind of lose focus in the middle of the problem and start like going the wrong direction. I do it all the time. So just double check your powers, make sure they add to give you whatever the exponent is. What do you notice about the signs on the final answer? Alternating between plus and minus. That's going to happen. If this is a minus, your signs are going to alternate. Now, if it's a plus, they're going to all be pluses. You won't ever get a minus if your original problem has addition. All right, let's try it again. This one, if I try to do this without the binomial theorem, I would have to multiply x plus 2 times itself 5 times, which would be absolutely horrible. So we're going to use the shortcut where we'll get a coefficient from Pascal's triangle, and then we have x raised to the 5th.
Wait, so why does it have to be 1?
Say it again?
Why does it have to be 1?
Well, the first and last coefficients on Pascal's triangle are all 1s. You don't have to write it if you don't want to. Okay, and then how do we know which row to use? It's the one where 5 is the second number. So this is the row we're using. So then we'll have 5. and then the power on the x is going to go down, and the power on the 2 is going to go up. And if you notice, the 4 and the 1 add to equal 5. Okay, and then looking at the triangle, our next number is 10. And then we go down, and we go up, and they're still adding to equal 5. And we have another 10. Which 5 are you talking about? There's a bunch of them. This one or this one? All of those numbers in the front are coming from this row. All right, and then from here, if you guys, like I said before, if you want to use your calculator, you can. Obviously, you can do 5 times 2 without a calculator. And you can probably do 10 times 4 without a calculator. We probably don't even need one, actually. 2 to the 3rd is 8. 8 times 10 is 80. 2 to the 4th is 16. 16 times 5 is also 80. Right. And again, there's not a minus in the problem. All your answers are going to be plus, or all your terms are going to be addition. All right. Any questions on the binomial theorem? It's not too bad if you can stay focused as you go through the problem. Yes, ma'am. It alternates positive, negative, positive, negative, positive, negative. Now, if you just do the negative 4 to the power, the signs will take care of themselves. You don't have to. I just always kind of like check myself at the end to make sure that's right. All right. What other questions do you guys have? All right. So the other thing we're going to do today is divide polynomials. And so I'm going to show you 2 division algorithms. One of them you probably are going to remember from Algebra 2, and the other one you're probably not. So it's okay. So if I'm going to take a function, I'm going to call f of x. I'm going to divide it by g of x. And f of x is called the dividend. I'm going to try to fit it. Dividend. That's usually the one people don't remember, dividend. Do you guys remember what g of x is? What you're dividing by, what that's called? Yeah, good. All right, so when you divide, what is the answer to division called? Quotient. Good, so we'll call that q of x. Quotient. If you divide and it doesn't go evenly, what's that called that's left over where it doesn't go? That's the remainder. So we're going to call that r of x. And then when you're writing your answer, what do you divide the remainder by? Do you remember? We've already used it once. The divisor. Good. So I think that's the one you're probably going to remember from Algebra 2. Now there's another one that's actually just taking this one and multiplying through by the divisor. So if I multiply this side by the divisor, what are you going to be left with? If you divide by g, or if you multiply by g of x, it's just going to be f of x. So this is the second division algorithm. It's f of x, which, if you guys remember, is the dividend. All right, and then I would have to multiply the divisor by the quotient. Because remember, I'm distributing the divisor. And then what do you get on that last term if you multiply by the divisor? just going to be the remainder. This is what I actually did, just to double check my answers to make sure that I didn't make some mistake dividing. I used that to make sure it gave me the dividend. All right, so if the remainder is 0, then that means the divisor is a factor of the dividend. Now, I think you guys probably remember that from Algebra 2. I think there was questions on the EOC that was like, is this a factor of this? And you would just make sure you got a remainder of 0. One thing you might not have done is, if it's a factor, you can find the remaining factors using the quotient. So using what you got when you did the division, you can factor that and keep going with the problem. I don't think you did that in Algebra 2, but you might have. Now, there's 2 types of division for polynomials, synthetic division and long division. Synthetic division is way faster. The problem is it's very restricted. So you can only use synthetic division when the divisor is either something like x plus c or x minus c. So x plus a constant or x minus a constant. That's when you can use synthetic division. Now, if you look at the little half sheet, there's a whole bunch more steps written on synthetic division, not because it's harder or longer, it's because it's just more tedious. It's more hard to articulate the words. But if it is not in that form, you're going to have to use long division. And the good thing about long division is long division always works. No matter what you're dividing by, you can do long division. All right, so we're going to do some examples of both. If you don't like synthetic division and you want to do long division all the time, you are more than welcome to. I kind of doubt that's going to happen, though. All right, so on example 3a, we're dividing by x plus 2. Can I use synthetic division? Yes. So I am going to. And I'm not going to read you all the steps. You can go back and look at them if you kind of forget what's happening, but I think you're going to remember. So on synthetic division, you have this little box. Do you guys remember, looking at this problem, what number is going to go in the box? It's good. -2. Good. It's going to be the opposite of whatever is here in the divisor. Do you remember what numbers go here? It's hard to articulate it. I think you do remember. It's going to be the coefficients and the constant of the dividend. Now you have to be careful as you do this. If there was a term that was skipped, like for example, that wasn't there, you do have to fill in a 0 for where a term is missing, but we're fine on this one. All right, so you're going to leave some space and you're going to draw a line. And this first number after the box is going to come under the line. And then from here on, it's just multiply, add, multiply, add. So you multiply the number in the box by the number under the line, and then you add. And then you multiply number in the box by the number under the line, and then you add. And then one more time, multiply, and then you add. Now, why did I separate the last number from the rest? That's the remainder. Right? And then these other numbers are the coefficients and the constant of the answer. Now, you can't give your answer as 1, -3, -10. That doesn't even really make sense. And so it's 1x to some power minus 3x to some power. So how do you know the power, the first power? It's 1 less. So if you take an x cubed and you divide it by an x, you're going to get an x squared. So this is going to be 1x squared minus 3x minus 10. That is your quotient. Is x plus 2 a factor of that dividend? Yes. So because it is, we can keep going on this problem. And so finding the remaining factors means taking that quotient and factoring it. All right. And then for D, we want to write the complete factorization. And so the complete factorization uses the factor from the beginning of the problem, x plus 2, and then the factors that you found. Did you guys do that in Algebra 2? I didn't think so. That's perfectly fine for me if you want to leave your answer that way. If you want to write it as x plus 2 quantity squared, that's also fine. I don't have a preference. You can do it either way. Okay, so that's synthetic division and completing a problem. Can I do synthetic division on number 4? Yes. Because it's just x minus 3. All right, do I need to fill in any zeros on number 4? Yes.
Where's the zero?
Well, because the terms were skipped. It went from an x cubed to just an x. There was no x squared term. You have to fill in a 0 there. If you don't fill in the 0, you're doing the wrong problem. So if it's an x cubed, a dividend, there has to be 4 numbers, or it's not x cubed, it's x squared. Yes.
So that first number, is that where it says divided by x negative 3? Is that where you get that from?
Yes.
So it's always positive?
It's always the opposite. The first one, yeah, the first one we did was negative. All right, so we bring down that 2 and we just start multiplying and adding.
How are you getting to?
You're multiplying and adding. So wait, do you have this set up? Okay, after that, this first number drops down, and then you multiply the number in the box by the number under the line and write it here, and then you add, and then you just do it again. 3 times 6 is 18, and then you add and get 14. 3 times 14 is 42, and then you add. All right, and then these are the coefficients, the constant, and the remainder. So it's going to be 2x squared plus 6x plus 14 plus, it's a positive 2. Is that what you're going to say?
I got 30. I got 32, not 42. Never mind.
Okay. The remainder is positive 2, not negative 2. I did mess that up.
So if you do the 0 minus 6, is that
It's 0 plus 6.
Oh,
So on synthetic, bless you, it's multiply, add, multiply, add. All right, any other questions? Yes, ma'am.
what's an x minus 3?
Okay, so you do, when you get a remainder, you put the remainder over the divisor. All right, what other questions do you guys have?
Yeah, where'd you get the grade from?
Those are the coefficients, the constant, and the remainder of your answer right here. And so if you have an x cubed and you divide by an x, it goes down to x squared. So that power, this original power, goes down by 1. And then you just continue to go down until you get to your remainder.
So it always goes down by 1.
If it's synthetic division, it's always going down by 1. All right, any other questions? All right, let's talk about long division. Well, first, can I do synthetic division on number 5? No. So if it's 2x or if it's x squared, we cannot do synthetic division, but we still need to be able to do the division. So we're going to do long division. So we're going to set this up like you guys did back in, I don't know, 5th grade. So the divisor goes in front, the dividend goes underneath. All right, I'm going to write an old-fashioned problem over here. Let's do... I don't know if this is going to work out well or not. We'll see. All right, so just like with division with numbers, your first step is to divide. And when you did this division back in whatever grade, when you were dividing, you really only focused on how many times will 2 divide into 8. You didn't really think about 21 and 856 all at one time. You broke it down. So same thing here. When I do this division, I really am going to focus on 4x cubed divided by 2x. And so what I do is I ask myself, what do you multiply 2x by to get 4x cubed? What would you answer yourself? Yeah. All right, so in this case, that would have been a 4. So you ask yourself, what do you multiply 2 by to get 8? All right, so on both of these, what would the next step be? Your next step is to multiply. So when you multiply with numbers, you wouldn't only multiply the 4 by the 2, right? You would multiply 4 by 21. You'd multiply it by 2, and you'd multiply it by 1. So we have to do the same thing over here. We have to distribute that 2x squared. So we have to multiply it by 2x, and we have to multiply it by the 1. All right, so on both of these, what is the next step? Subtract. Now, subtracting with polynomials is way more difficult than subtracting numbers. So we have to subtract both of these terms. We can't just subtract the first. We have to subtract both. Now, on this step, these have to subtract to 0. If they don't subtract to 0, then you messed up. But they do, so we're good. All right, so they cancel, and then we have negative 6x squared minus 2x squared is negative 8x squared. Okay, what's the next step? On both of these. The next step is to bring down the next term. Now, I didn't do a great job making up the other problem, so it's okay, it's fine. Now we're going to repeat that pattern. So the first step is to divide. So when you're dividing, I think it's helpful to ask yourself, what do you multiply 2x by to get negative 8x squared? Negative 4x, good. That's what goes up here. Then you're going to do that multiplication. So multiply this by that negative 4x. Now, it's important we subtract both of these. Subtracting both of these means we're changing both signs. Now, I just do this out of habit. I've been doing it so long that whenever I'm doing my subtraction step, I change the sign and I circle it just so I tell myself that I did it. So I change both signs, and then I'm ready to combine my terms. And so the 8x squareds cancel out. You're left with negative 4x. And then we're going to bring down. I'm going to color code this. All right, and then we're going to do the divide step one more time. And then multiply. Oops. And this one works out nice. You get a remainder 0. And so this is my answer. Is 2x plus 1 a factor of that dividend? It is, yes. All right, so look at these steps. See if there's something that's missing in your brain, connecting everything. We are going to do one more. All right, so this last one, we're going to use everything we learned the whole day today. So we're going to take the quantity x minus 3 to the 4th and divide it by x squared minus 2x. Now, can I divide it when it's in that form on the top? We're going to have to expand it first. All right, so I am going to have to use Pascal's triangle. And since it is raised to the 4th power, I'm going to find the 4 in the second number, and that's the row I'm going to use. So 1x to the 4th, right? And then we have 4. The x power is going to go down. Negative 3 power is going to start going up. Okay, I went through that kind of fast because we're running out of time, but those powers, they are either a 4 or they add to be 4 in each term, which is what we need. And then this was a minus, so my signs are alternating, positive, negative. All right, so we're ready. Can I do synthetic division on this problem if I'm dividing by x squared minus 2x? No. So here we go. So many places for you to make a mistake because you just have to write everything so many times. All right, so when I do the division step, I only care about the first terms. And so if I ask myself, what do I multiply x squared by to get x to the 4th? That's going to be x squared. And I didn't talk about it in the last problem, but I always keep my terms lined up. So even the quotient I keep lined up. You don't have to do that on the top. It just makes it easier for me. All right, then I'll multiply. And change both signs so I can subtract. And then bring down. Okay, and then I'm ready to divide again. Multiply. And subtract. Bring down. And then one more time. All right, right, now this problem is kind of set up in a way to make you mess up on the remainder. Negative 40x is actually not our complete remainder. What else do I need to do? I have to bring down the 81. Now I can't keep dividing because this power is less than this power. But that does have to, everything has to come down eventually. All right, so I want to write this using both division algorithms. I'm going to have to squeeze it. All right, so the first one, we take our dividend over the divisor, and it's equal to our quotient plus the remainder. Oops, plus the remainder over the divisor. Right, and then the other one, we're just going to multiply through by the divisor.